Good evening. My name is Richard Krutop. I'll be going over the MILSTAR failure, and I labeled this one the unacceptable disaster, unacceptable failure. Slide. So a little bit background about the MILSTAR. MILSTAR is called the Military Strategic and Tactical Relay. That's what MILSTAR is abbreviated. MILSTAR provides a strategic communication for all U.S. government leadership. Some of the U.S. government leadership range from the President, Secretary of Defense, and different U.S. United States Armed Forces. This is basically the backbone for the U.S. to do worldwide communications with both DoD, U.S. government, and other agencies. Now, the U.S. MILSTAR was going to be located at GeoSat, and it would provide that 24/7 coverage for each portion of the globe. The constellation would consist of 6 different satellites and 6 different AORs, and some of those AORs consisted of Eurocom, U.S. NORCOM, U.S. NATO Pacific Command, etc. Again, the constellation would provide communication between ships, submarines, land bases for all different services like the Navy, the Army, the Air Force, etc. And the MILSTAR constellation was going to be worth over $6 billion. Fast forward to present day, MILSTAR was a successful constellation, and it was continued with the advanced extremely high frequency satellite constellation AEHF, and that constellation has already been completed, but MILSTAR was the precursor to that and provided that global communication for any personnel that needed that type of communications. Now, MILSTAR was divided between different blocks. The first block had 2 different flights. Flight number 1 consisted of both each MILSTAR had 2 payloads. One payload had a low rate. For the block 1, had a low rate payload, and on the other side, it had a classified. For the first flight for MILSTAR Block 1, that classified payload was scrapped and was flown on the flight 1, even though it did not work. The second time they launched the MILSTAR Block 1, Flight 2, they launched also the low data rate payload, but they placed a aluminum container so that the spacecraft could have the same center of mass and characteristics as the previous one. Now, the low data rate payload had the ability to transmit 75 to 24,000 bits per second, and that was one of the key factors of the experimental missions. Now, when we get to MILSTAR Block 2, or the MILSTAR 2 failure mission, that was actually a hybrid between the MILSTAR Block 1 and MILSTAR Block 2. What made it a hybrid was MILSTAR. It had MILSTAR Block 1 subsystems, while it had both the MILSTAR Block 2 payloads, which had both the low data rate and the medium data rate payload. Now, the medium data rate payload was a new payload for the constellation, and it would increase the bits per second that would be transmitted from one section of the globe to the next at 4,800 bits per second to 1.544 megabits per second. Now, as I stated before, each of these spacecrafts ranged from 700 to $1 billion to push up. So it was a very expensive satellite to lose, and it was very vital that we had successful missions. failure rate should have been 100% for an ACAT-1 system, which if you are in acquisitions, this is your highest category of programs that you fund at. So, for example, the F-22 was an ACAT-1 system. F-35 was an ACAT-1 system because they are high value dollars programs that cost a lot to design, develop, and then if you have the program fail, that usually means you have wasted a lot of the taxpayers' money. So even one of these spacecrafts, if they didn't make it into orbit, would have been a very big failure for any organization. And since the Space Force is such a small, well, at that point it was the Air Force Space Command, and at that point it was a one-off from the Air Force. I don't want to go to the point of saying they were the best or they were the stepchild of the Air Force, but they received, they divided up the money as best they could. But when Air Force divides up money, usually they look out for their air breathing systems more so than their space systems. But the Space Force knows that these systems give global service to not just the Air Force or the Space Force, but to all DoD partners. So when they look to get out year funding for some of these programs, they need to think bigger picture about Space Force. And that is another reason why the Space Force eventually became its own brand, because it's such an important aspect to the architecture of the DoD and the military mindset. So getting into the MILSTAR 2 failure. Now, leading up to the MILSTAR 2 failure, there had been already two different failures. One was a NRO mission, Mercury, and if you know anything about the NRO is National Reconnaissance Organization, and they provide reconnaissance satellites, and usually they are very, very expensive satellites. We're talking another billion to ACAT-1 system program office, so another very expensive program. So the next program, which was almost 6 or 7 months later, was the Defense Support Program, which was another high-valued program. As you can see, leading up to the failure, these two programs were very, very expensive. Going into why we were using the Titan at one of the aspects of Titan 4 was that we were looking for a launch vehicle that would replace some of our aging launch vehicles, and Titan program came out of that. And the Titan program came out of also from the 1986 Challenger disaster. From that, the Challenger was a space shuttle that we were trying to use to get spacecraft into orbit. After that disaster, that was another driver to get the Titan program situated. But the problem with the Titan program was they were running up costs, and there was a lot of delays, and we weren't getting the most bang for our buck. Also, the Titan was designed not as a launch vehicle, but as an intercontinental ballistic missile. So the Space Force was using a missile to put a spacecraft on top, and not saying that all the safeguards were put in place, but to me, it seems like you're building a bullet and you're trying to exit. You're building a system that wasn't built to execute a different mission. So the mission for the ICBM was to fire, to a different country and then deliver whatever nuclear warhead to that country. This other mission was fire, deploy a upper stage, and then the upper stage pushes the craft to the next orbit, usually GEO for most of these high value spacecraft, and then that upper stage releases the spacecraft. So it is a little more intricate to do that type of mission. So for me, the Titan IV wasn't built to launch spacecraft, but was built to deliver nuclear warheads to different countries. So going into the MILSTAR failure 2, MILSTAR 2 was launched on, again, a Titan IV. It was launched on May 1st, 1990. Nothing happened on the first stage. Everything was nominal. But during that upper stage, they had misfires 3 times, had not the correct timing, and had different durations that could have got it to the particular mission. They tried to separate it, or it separated at lower orbit. The mission operators took over, tried to salvage the mission, tried to get the spacecraft into the proper orbit, but it could not. It did not have enough fuel to get it to that orbit. Later on, they found out